This is very urgent that we get through this quickly. You have no idea. Tables, equations, and graphs. All right, now we're going to peer into the future. Make a prediction based on this information they give us in the table. What's the estimated value going to be in the year 2012? And so, the best predictor of what's going to happen in the future, look at what happened in the past and look for the pattern. So, a year goes by. I look over here, the value dropped $2,000. Another year goes by, 1 year. I look over here, the value dropped again. Not sure how much it dropped, so I got to subtract. 13,000 minus 11,500. I should get 1,500. It dropped that amount, so negative 1,500. Another year goes by. Years keep going up by 1. The value keeps going down. From 11,500 to 10,500, just subtract, and you see it drops by $1,000. So there's a pattern here. Do you see it? Drops 2,000, then drops 1,500, then drops 1,000. How much is it going to drop next? If you say it's going to drop 500, right. So when it drops the next time, I'm expecting, my prediction is that, well, according to this pattern, it's going to drop by $500. So then what's the value going to be? It was 10,500. So just subtraction. 10,500. Go ahead and subtract 500. I'll wait. I can't hear you. 10,000. 10,000. So our prediction is that for 2012, the estimated value of whatever item this is going to be $10,000. That's the idea of how you use a table to make predictions about the future. Boom. Let's do this. Tables, equations, and graphs. All right, we're going to use this graph to not make a prediction, but to analyze the situation. So the situation here, I can tell it by how do they label the x-axis and the y-axis. So these numbers here all represent hours. These numbers here all represent distance in miles. So 1 hour, 2 hours, 3 hours, 4 hours, 100, 200, 300 miles, so on. Do your best to go ahead and sketch this and copy those questions down. I know it's a lot, I just did it. I'll wait. Done so fast. Okay, can't wait to see these notes. Alright, so first part, estimate the distance traveled after 2.5 hours. So, like so. 2.5 hours. That is about right here on my x-axis. I'm going to extend this imaginary dotted line up to the actual graph. Intersects it at that point. Then I'm going to line it up with the y-axis, the distance. So 2.5 hours corresponds to between 100 and 150 miles. Would you say it's closer to the 100 or closer to the 150? Closer to 150, right? So make an estimate that's closer to 150 than it is to 100. I'm going to go with 140 miles. Estimate So, reasonable answer. Number 2, similar type question about how many hours, so we kind of flipped it, how many hours will it take to travel 250 miles? So we're given 250 miles. 250 miles is right here. I'm going to extend 250 miles out to the graph. It's about that point. And now I'm going to drop directly down onto the x-axis and see where does it line up at. And according to my calculations, it's between 4 and 5 hours. It looks like it's closer to 5 hours than it is to 4 hours, so it's more than 4.5 hours. So make an estimate. It says about how many. Something that has to be bigger than 4.5 and less than 5. I'm going to estimate 4.7 hours. What's that? You said 4.8? Okay, 4.8 hours is a good estimate also. So, the good thing on these problems is there's room for you to estimate. So it doesn't have to be an exact number, it just has to be reasonable and within that range. So this is how you would use a graph and read the graph to answer these types of questions. That is 8.58. So now, go to the little island, call up your buddy, and study. Have a good evening.